This time we're going to have a quick look at what's called the quotient rule. And like the product rule, it's a way of dealing with functions that are joined together. So the product rule we use to deal with something like e to the x times tan x, and we showed how to do that using the product rule. What say we had two things that weren't joined together by multiplication, but they were joined together by division. So exactly the same, except that the two things are divided rather than multiplied. I don't have a bad maths joke for division, but I have to work on that. Okay, so here we've now got y is u divided by v. And if you look on the formula sheet, you will find it tells you that y dash is u dash v minus u v dash divided by v squared as the formula for the quotient rule. So let's do exactly the same as we did before. Make up a little table. So we're going to have u and v and dashes. So u dash, v dash. U is on the top. It does matter, you've got to get top and bottom right. Because over here, they're clearly different. U's and v's are playing different roles. And the product rule, it didn't matter which way around you got them. But in the quotient rule, it does. So u is on the top, and v is the one from the bottom. Differentiate them both. Differentiate e to the x, differentiate tan x, sec squared x, just straight off the formula sheet. So the derivative of this function is u dash times v minus u times v dash, all divided by v squared. So that's just tan x squared. Okay, so again, very simple. Identify your two pieces, differentiate them each separately, stick them together using the rule that you find on your formula sheet. So let's have a go at another one. Y equals natural log of x over 5x to the power of 3 plus 2. That'll do. That's quite a cute one. And let's have a look and see. So exactly the same process. U and v, and u dash, same idea. So u is always on the top. So natural log of x. V is whatever's on the bottom. Differentiate them each separately. Differentiate natural log of x. Formula sheet tells you it's 1 over x. Differentiate 5x cubed. That's going to give us 15x squared. Plus 2 is a constant, so that turns into nothing when you differentiate it. And then we just stick it all back together again. So the derivative is formula u dash, that's 1 over x, times v, 5x cubed plus 2, minus u, which is natural log of x, times v dash, which is 15x squared, all divided by v squared, that's 5x cubed plus 2 squared. That's the end of the calculus, that's the end of the differentiation. It may be that you can expand some brackets or cancel some bits out, and it may be able to be simplified, but that's an algebra story. And quite often in your calculus exam, you'll see it says things like simplification not required. So that stage is fine. When you get on and you do stuff where you're actually going to try and use these things, simplification can be really helpful. But at this stage, just doing the differentiation is what is required. So that's the idea for a quotient rule. So it's very easy to identify. It's the one with the big divide line through the middle is the one you want to use the quotient rule for.